Okay, I'd like to talk about recursive patterns. I mean, just read this through. It's a recursive patterns. It's a pattern rule that relates between the preceding term and a successive term in a sequence. So now, so the way to understand or the way to get a general term of any sequence that is given as that is represented by the recursive patterns is first using patterns, okay? And then the second way could be using the part recursive. So now first using patterns just means that you gotta list you gotta list them and do not compute them. Let me show you how this is done. Okay, so okay. Okay, it's right here. So now, let's talk about arithmetic sequence first, and then let's talk about what the first way implies. So, like I said, do not compute, right? But you gotta list first, but you should not compute. Okay. Then first, it's done by this. So first, when n is 1, then you have a2 minus a1 is 2. Then you have a2 is a1 plus d, right? And then if n is 2, then a3 minus a2 is d. And if you simplify this for a3, then a3 is a2 plus d, right? But now, what I mean by not compute is in an actual sequence, a1 and a2 are likely to be given as numbers, you know. But I didn't give you numbers, so what I mean by do not compute is that do not add a1 and d together and then get a, for example, like a1 is 2 and d is 3, then do not make it 5. Okay, just leave it at 2 plus 3. Okay, now then this becomes a2 plus d, right? Then now a2, you can replace that with this result. Okay, then it is a1 plus d, right? Now, if n is 3, then it's a4 minus a3. Then this is also d, because whatever you put in, what this equation means that whatever n you take is always d, right? So this is an arithmetic sequence, right? So a4 is going to be a3 plus d, and the a3 is replaced by a1 plus d plus d plus d, right? But now I think you're allowed to compute right now because you see a little bit of pattern going on here. Now, as you see, this is 2D, right? 2D. And then this is 3D. 2D and then 3D. And then this is just D. And as you just no, I'm saying this is just D. Yeah. What I'm saying is A2, when it's A2, it is 1 plus 1D, right? A3, it is 1 plus 2D, right? And A4, it is 1 plus 3D, right? Therefore, in the case of AN, that's where we are going, right? AN should be A1 plus n minus 1D, right? So the patterns that we could find out from just listing them and not computing them fully is that we were able to see that these numbers here, like sub numbers here, the sum of the sub numbers on the right hand side here will generate the sub number here on the right on the left hand side. So 1 plus n minus 1, right? 1 plus n minus 1 generates n. Okay? And all right, then so well, I hope you practice this with a real sequence. So for example, I'll give you a practice where an plus 1 minus an is 3. Okay? And then a1 is 2. Work this out. Work this out and tell me what you get down in the comment section below. Okay? Now, now you got to use the recursive one. Recursive. So I use the patterns though. Maybe I need to use a different color for that one. So maybe this color here. You gotta use the recursive one here. The recursive. Then how do you use a recursive? Like I said, I gave you a hint here, which is these are all done by algebraically. Okay, algebraically. So what I mean by that is you don't need to list anything. You just need to just solve equations and equations and equations. That's it. So now as you see that A2 minus A1 is D, A3 minus A2 is D, and A4 minus A3 is D, right? Now, I wrote them vertically like this, but how about I write them horizontally? So let's just say this is number 1, this is number 2, and this is number 3. And if I write them horizontally, then A2 minus A1 plus A3 minus A2 plus A4 minus A3 and so on and so forth until you reach an minus 1, right? Then how many D's do we have? We need to count here, right? 1, 2, 3, all the way up to n minus 1. So now we have n minus 1 D's, right? N minus 1 D's, right? Because these are all D's, right? Therefore, now let's compute them. Then you see A2 here, right? If you, by the commutative property of addition, so A3 plus negative A2, like this, you can switch them like this, A2 plus A3, like this, right? By the commutative property. And then you do so as you go all the way down, right? Then now negative A2, A2, A3, A3, A4, and A4, and then everything like cancels themselves, right? I mean, pretty much like everything goes away except the first term and then the last term here, which is an. Therefore, what you have here is an equal an minus a1 equals n minus 1d, and then this is an is also equal to a1 plus n minus 1d, right? So, well, whichever way you go, you get the same result, right? So, but adding this horizontally, it's not very effective, I should say. I did it so that I could make you help you understand. So, adding them vertically, like when we solve linear equations, like a system of linear equations. So now we see that we have systems of equations here. That now just think about, imagine we add them all together like this. Now what happens here is that now again counting these first, then if you add all of things on the right hand side, it's going to generate n minus 1d, and then if you add everything on the left hand side, then as you see A2 they cancel each other out, A3 they cancel A3 they cancel each other, and so on and so forth, and then an and then negative a1 minus a1 is the only thing that is on the left hand side. Therefore, this is an minus a1, right? So now you just move a1 to the right hand side to get the same result. So, well, adding them vertically is more preferable here in this case. Okay, now let's move on to the next one. So again, maybe I'll ask you to pause the video. Yeah, pause the video, and then come back. All right. Now, first, do not compute, right? Let's try the first way here. Then what that means is, now if n is 1, it is a2 over a1 is r. Therefore, a2 is a1 times r, right? And if n is 2, what happens here is that a3 over a2 is r. Therefore, a3 is a2 times r, right? Now, since we know what a2 is, so this a2 gets replaced by this. Therefore, then it's a3 a1r times r, right? Because I replace this a2 with a1 times r. Therefore, it's a1 r squared, right? Now, one step further, then a4 and a4 divided by a3 is also r. A4 is A3 times R. We do know that what A3 is, so this A3 gets replaced by the result here, then it's going to be A1R squared times R. Therefore, this is A1R to the power of 3. As you see the patterns here, right? When this is 3, it's 1, 2. When this is a 4, this is 1, 3. When this is 3, this is a, I went over that. When this is 2, then this is 1, 1, right? Therefore, we can definitely conclude that when it's an, we have a1 and r to the power of n minus 1. right? Therefore, 1 plus n minus 1